Okay, for something like number 8, I'm really hoping, before I proceed in this problem over here, that it's an odd integrand, because I'm seeing those symmetric limits over here. So f of x, and if it is, it would be 0. I'm not saying that it is odd, but it looks very unlikely at this point. So f of x, just looking at it, it does not appear to be f of minus x. All right? And just if you plug in the minus x, you get 1 plus x squared on top. On bottom, you get 1 plus 2 over x. It's just not working out. All right? It's definitely not odd. So now I'm left with I'm going to say a conundrum. How do I do that? And I don't have many techniques for it. So what I want to do is I want to go to the whiteboard and then start the struggle with it. All right? Let's do that. And I'll write it down for you. And I'm seeing over here an integration. It looks like an awful integration to me. I'm going to say if they ask me the integration, I probably can do it though. 2, that's 2, 1 plus x squared. And then on the bottom, I get 1 plus 2 to the x. And then I get a dx over here. Now, I'm going to try something that, maybe it's going to work, maybe it's not going to work. But I'm going to make this like, I see the symmetric limits. I'm just going to say u equals. I'm going to say it equals to minus x. Or I could say minus u is equal to x. Really the same statement. So I'm going to take the second one, and I'm going to start to do a u substitution and see if anything gets better in the problem. And as I do that, this is going to be minus du is equal to dx. All right, let me put this down. It's going to be equal to. Now, if x is minus 2, u would be 2. If x is 2, u would be minus 2. Then what do you get over here? You get 1 plus, x squared would be minus u squared would be plus u squared. And then dx would equal minus du. What do you get on the bottom? 1 plus, x is minus u, so 2 to the minus u. I'm going to write a little bit different, and I realize that minus on the outside kind of disturbs me. So really it's going to be minus 2 to 2, 1 plus u squared, 1 plus 2 to the minus u. And then I get a du there. Now, by the way, it really didn't do much. Right? I don't think it did much there. But what I want to do is I want to try to multiply the top and the bottom by something that gets rid of that negative exponent. And I'm going to put that down for you. So I'm going to put it down. This is the same thing as minus 2 to the 2. And this is going to be 1 plus u squared and 1 plus 2 to the minus u. And I want to get rid of that negative power. So I'm going to multiply the top and the bottom by 2 to the u. Let me write that down for you. So what do you get? Minus 2 to 2, 1 plus u squared, 2 to the u. On bottom, what do you get? You get 2 to the u plus 1 du. Well, this looks sort of familiar. So what I want to do is I want to go back to the land of x's now. So I'm going to make another substitution. All right? So I'm going to say over here that the original integration I wrote down, which was minus 2 to 2, 1 plus x squared, this is this guy over here, over 1 plus 2 to the x dx is now equal, I'll tell you what I'm doing over here. I'm going to say u equals x, du equals dx. I'm just going back to land of x's. What do you get? Minus 2 to 2, 1 plus x squared, 2 to the x, 1 plus 2 to the x. Yes, I did a commutation error, dx. All right? And then what am I going to do? Well, I'm going to add, it's an equation, by the way. I'm going to add this thing to both sides. And if I did that, I would get minus 2 to 2, 1 plus x squared, 1 plus 2 to the x, dx, plus, let's write this down, minus 2 to 2, 1 plus x squared, 2 to the x, 1 plus 2 to the x, dx equals minus 2 to 2, 1 plus x squared, 2 to the x, 1 plus 2 to the x, dx. Oh, I had two. I'm sorry, there's two of them there. I'm sorry. I said add to both sides, by the way. Let me take a look at that, make sure I did that right. Yeah, add it to both sides. Looks pretty good. Then what I'm going to do is I'm going to take these two and pull them together. Let's write that down. So minus 2 to 2. They have the same denominator. It's 1 plus 2 to the x. I'm going to look at this guy and this guy. I'm going to pull it together. And what do you get? 1 plus x squared. 1 plus 2 to the x equals 2. 1 plus 2 to the x. 1 plus x squared, 2 to the x, dx. What do I notice now? This cancels. Let's write this down now. So you get minus 2 to 2, 1 plus x squared, dx is equal to 2. Let's see, 1 plus x squared, 2 to the x, 1 plus 2 to the x, dx. Boy, it almost seems like it's just never going to end, right? Like, at least integrate the left side. And let me go through that for you. So what do you have there? You get x plus x cubed over 3, limit of integration from minus 2 to 2. This equals 2, 1 plus x squared. I forget to write this down, I'm sorry. Let me see if I did that above. No, I got it all written down there. 1 plus x squared, 2 to the x, 1 plus 2 to the x, dx. Is this ever going to end, by the way? I'm still kind of wondering about it. And let's just do the arithmetic over there. And I'll do it on a side by, because I want to keep writing this thing over again. It's 4 plus 64 thirds minus, I'm sorry, I made a mistake there. Got to erase it. It's 2 plus 64 thirds minus 2 plus 64. I keep doing it. I guess I'm tired. I gotta really take a break. But anyway, 2 plus 8 thirds, my mistake, by the way. And then it's going to be minus 2 minus 8 thirds. Sorry about that. So 2 minus a minus 2 is 4. And 8 thirds minus a minus 8 thirds is 16 thirds. And what do you get there? 3 times 4 is 12. 12 and 16 is 28. 28 thirds. I'll write that down. 28 thirds is equal to, forgot to do that again, plus 2. 2 minus 2, 2, 1 plus x squared, 2 to the x, 1 plus 2 to the x, dx. I'm going to divide both sides by 2. And what do you get? You get 14 thirds equals minus 2 to the 2, 1 plus x squared, 2 to the x, 1 plus 2 to the x, dx. Wow, what's that thing? I know the integration of that thing, but I'm going to go back over here, and I want to point out this here is identical to this thing over here. So what have I really found? I found that the answer to my question and again, it's a long process, but we found the answer. The answer is going to be 14 thirds for that particular problem. That was not an easy integration to do. It took me time to think about that. Thank you.